0829 7477 2477 2531 8999 8951.
Autistic people, they say, are in a world of their own, and that's very true, because he can shut the outside world out. We think of like other things, mortgage, food, doing this, being here, there, and he can shut all that out and just solely concentrate on what his numbers.
We have taken Howard for tests at the London laboratory of mathematics expert Brian Butterworth. With the new procedure, he can measure the oxygen-dependent reflectance of light in the blood, therefore brain activity, faster and with less stress than with an MRI scanner. After hundreds of such tests, Butterworth has deduced that although the memory's capacity for numbers certainly depends on practice, it is mostly down to our genes.
All right, Howard, let's do some prime numbers. What is the nearest prime number to 2,000?
1999.
Okay. The nearest prime number to 7,000?
7001.
I've proposed a theory called the numerical module theory. And essentially what this says is that there's a set of neurons, brain cells, in your parietal lobes that is specialized for numbers. It's something which has an ancestral version in lions and monkeys and dogs and cats and other, and birds indeed, other species that we've looked at. And it's for detecting what one might call the numerosity parameter in the environment. That is, how many things there are in a set of things. And if you haven't got this, you're going to find it very difficult to learn anything about arithmetic. And if you have got it, this will form the basis of more advanced arithmetical skills.
In San Francisco, researchers working for NASA are using further tests to try and decipher the secrets of the infinite Kimputers hard drive. One initial theory suggests that Kim, like all savants, has access to the raw material of his memory. This means that the particular mechanism of filters that most people use to collate and evaluate information and forget what is not relevant doesn't work with Kim, or at least not in the usual way. Kim, however, has learnt to swim in a sea of memories because, after all, nothing is as adaptable as the human brain. But how Kim keeps his head above water is something that is still completely unknown. A look inside his head reveals that in Kim's brain, the liquid-filled ventricles are much larger than usual. They normally fill the space between the limbic system and the cortex. With Kim, they extend as far as the cerebellum, the human motor memory. The cerebellum, which normally consists of two equally sized halves, is asymmetrical in Kim's case. The left half of the cerebellum is clearly smaller. As yet, this explains only one thing: the somewhat awkward and occasionally clumsy movements of this memory master.
Here's the brain.
Whose is that?
That's your brain.
With a new technique called fiber tracking, researchers now even have evidence of connections between regions of the brain. In San Francisco, the experts using this procedure make an amazing discovery. Kim has no corpus callosum, the large bundle of nerves, here colored red at the lower end of the cortex. It normally connects the two cerebral hemispheres. This is usually only seen in so-called split brain patients, usually epileptics, who have had the connection surgically removed, with astounding results.
If you show them something only in one side of their visual field, only one half of their brain will see it, the other half will be unaware of its existence. So for example, in a normal person who has his language centers in the left brain, if you show an object, say an apple, to his right brain, he will be unable to say what the object is, because the speaking half of the brain is not aware of the object.
This doubtless explains Kim's magic trick of being able to read 2 pages of a book at the same time, with one eye on each page. Maybe this is also why Kim simply can't explain to his father why he looks through old directories in the library day after day in order to write up endless lists of names in his notebooks. Put simply, in Kim's brain there are 2 separate hard drives on which to store his data. But does that explain his continuous access to all his memorized facts? Why doesn't Kim's brain have a delete key? And what exactly is it in us that decides who and what we consciously remember? From the point of view of our billions of neurons, every memory is essentially just a pattern of electrochemical stimuli. No matter whether they're storing 12,000 books, our first love, or other mysterious talents.
With the human, you have to understand that the central nervous system is continually replacing itself. So the cells that I have in my brain now are different than they were 2 or 3 years ago. And so I had to replace all of those. And there had to be a mechanism to store that electrical impulse in some neurochemical way. So it's an interaction between the chemistry and the electrical charge, and it is a complex interaction that we're really only beginning to understand.
Every ordinary person knows exactly where to find their favorite yogurt in the supermarket. They know hundreds of shops and thousands of prices. But we screen out millions of details so we can concentrate on the essentials. The downside is we always think along the same tracks. The next episode of this journey therefore looks into an even more amazing human skill: creativity. Is it possible that each one of us not only has infinite memory lying dormant within, but also other, completely different talents?
We are designed to see the ultimate label, not the parts that made it up. We see the whole, not the parts. But many people could argue against that. So this is an experiment that takes you, anyone out there, pulls them in, does this, and shows that they can have savant-like skills. By turning off part of the brain, not by stimulating it, or by turning off part of the brain.
In a Sydney laboratory, Alan Snyder is trying to simulate a knock on the head using magnetic impulses, not in order to improve our memories, but to improve our ability to be creative. Like the savant Alonzo Clemens, who makes sculptures of animals in minutes. We'll meet him in our next episode, along with Matt Savage, who learned to play the piano overnight and who released his first CD of his own compositions at 7 years of age. Above the roofs of Rome, we'll meet Stephen Wiltshire, known as the Living Camera. He wants to draw a 5.5-yard panorama of the immortal city, entirely from memory. Also, the mysterious Tommy McHugh. After a stroke, he instantly discovered a talent for painting. How many talents like these lie hidden in our heads? Mental arithmetic whiz Rüdiger Gumm also has another amazing talent. He can speak backwards fluently, word for word. We tested him with Heinrich Heine and Bertolt Brecht, and with one of Germany's most famous poems, Das Lied der Glocke, by Friedrich Schiller.
Nahm an Kräften wieder einmal zu.
I started speaking simple words backwards at 1.5 or 2, before I started speaking forward. At 6 or 7 I started to read my comic books backwards.
Mit 6 oder 7 meine ersten Comichefte von rückwärts gelesen.
Warum? Why?
Ich weiß es nicht mehr.
I don't remember. It was fun. It was something the others didn't do.
Andere gemacht haben,
I always enjoyed doing things the others couldn't do.
die andere nicht gekonnt haben.
Festgemauert in der Erden
3 Uhr mek zefniret netre.
steht die Form aus Lehm gebrannt.
Tets in Bruf suam held narbek.
Heute muss die Glocke werden.
Et tue sum it ekolk netre.
Frischgesellen seid zur Hand.
Schirf nelesek dias rutstna.
Von der Stirne heiß.
Nofred inrits sia.
Rinnen muss der Schweiß.
Nenner zum Red Siavsch.
Soll das Werk den Meister loben.
Los sat krevnet Red Siam Nebol.
Doch der Segen kommt von oben.
Kot Red Neges Mok noch Nebo.